Greetings, everyone. This is Brother Nicholas from Kush Coast Communications. Tonight's presentation is called Military Applications That Ponder Flat Earth. Tonight, I want to start by showing you the Corona program in the 1950s that went into the 60s. Let me go ahead and screen share that for you guys. Okay, right here, this was declassified in the CIA Cold War records. This was America's first satellite program. If you guys want to look that up, the program was called Corona. This right here is a document that I pulled from Google called Motion of a Sphere on a Flat Plane Terrain. It was published by S.H. Lee and R.S. Chadwick. And I'll just kind of read a highlight of this document titled Motion of a Sphere on a Flat Plane Interface. Okay, now in this document on page 706 that Chadwick and Lee published, it states the following. Used in the general solution of Laplace equation in bipolar coordinates to study the motion which is caused by the slow rotation of a sphere near an infinite grid plane when the axis of rotation is parallel to the plane. O'Neill, 1964, also investigated the translational motion of a sphere parallel to a plane solid wall. Finally, Bart extended the general solution of Jeffrey for asymmetric flow to the motion of a spherical drop, which is moving normal to a liquid-liquid interface. And I highlighted something here as well. Papkovich-Neuburr solution for Stokes equations, which right here they're quoting mathematician Stokes had various math formulas in physics for Stokes equation to solve for the motion induced by Stokes near a fluid-fluid interface. He superposed linear solutions with arbitrary coefficients to satisfy boundary conditions on the interface, namely the continuity of velocity and stress. However, the normal velocity at z equals 0 is not 0 in a solution, which implies that the interface is not steady. Because of this, the solution is only valid at the initial instant that the Stokes is imposed. And then I'll skip down to where they're talking about Laplace equations. The extension of his theory is to non-spherical bodies and to shear and Pollock flows has been carried out by many investigators. Citation, Happel and Brenner, 1973. So here, as you see in this document, and going back to the 60s, they're in various academic papers, they're basing their math physics on non-spherical bodies. So just something to look into, guys. Okay, this next document here was published by the National Reconnaissance Office. It was declassified and released in July of 2015. This document right here is for the acquisition optics subsystem. Basically, what this document here is, I got some other documents about this. This is just the cover page. If anyone's interested, I'll be sending out the secondary pages. This right here is for various camera devices that they're saying that they're using on certain satellites and military applications for certain reconnaissance planes. So they're just kind of going over how they're setting their cameras up, how the lenses work, and how these lenses take pictures of the terrain, whether you believe it's flat, spherical. We could save that for another discussion. I just kind of want to show you certain declassified documents tonight, whether they be from military applications or various academia, so you guys can see stuff, whether they be PhD papers, people that wrote master degree theses, military publications. So you can see the highest level information when people are debating this flat versus spherical terrain of our Earth. Okay, let me take you guys to the next document. Okay, this one's just getting into kind of some abstract stuff about math. This document here was published by Peter Grunwald and Paul Vitani. In this abstract, they're presenting what is called algorithmic information theory. And what it's saying here is we explain the main concept of this quantitative approach to defining information. We discuss the extent which Kolmogorov and Shannon's information theory have a common purpose and where they are fundamentally different. We indicated how recent developments within the theory allow one to formally distinguish between structural, meaning meaningful, and random information as measured by Kolmogorov's structure function, which leads to a mathematical formalization of Occam's razor and inductive inference. We end by discussing some of the philosophical implications of the theory. So I'm not going to get too much into that right now, but that's just to kind of show you how when we start discussing information and data sets, how we're distinguishing between meaningful information and random data. Okay, this right here is just it's a screenshot of a picture where they're showing satellites in space. And in some of these documents I was reading, it was showing how the aluminum, the reason they coat satellites with aluminum is aluminum has the best properties to reflect light. So in the 50s and 60s, when they were experimenting with a lot of radar and GPS applications, and they were bouncing signals off the atmosphere, this was some of the kind of illustrations they're using, and they're experimenting with different material compounds such as aluminum to see how they could bounce signals off the atmosphere. Okay, this document right here, this was titled Antarctic Research Elements of a Coordinated Program. And basically, this document is just getting um, re, reconnaissance mapping by the military when they were taking pictures of Antarctica. But something I want to draw your attention to, you guys, is right here. I highlighted some of this for you guys. It says to produce recon maps of a large area, it is desirable to secure photography at an altitude between 20 and 40,000 feet above terrain. The smaller scale photography at the higher altitudes would give all the detail desired for reconnaissance mapping and would require fewer flight lines, less control, and shorter time for compilation. Photographic coverage at heights of 20,000 feet would require approximately 225,000 linear miles of flying to cover the entire continent of Antarctica. If aircraft is capable of flying 40,000 feet could be used on the project, approximately 60,000 linear miles would provide adequate coverage of the continent. As a means of extending control into the interior, it is desirable that photographic flights be made parallel to the coast for a depth of 100 miles or more. For general purposes, a contour interval of 1,000 feet is recommended with supplementary contours. Okay, on to the next document. This one's about the Australian Space Center, various launch services. I'll save that for another day. It's just another website where this company has takes pictures of the Earth terrain. As you see a little bit to their left here, they have rocket missions, balloon missions, and student programs. If anyone wants to look this up, I believe Estrange is in Switzerland. Yes, Switzerland, Estrange Space Center. Okay, here we go. Right here, let's start getting into some military applications, family. This right here is called the MQ-4C Triton. This is a new broad area maritime surveillance, subtitled BAM, or abbreviated as BAMS, Unmanned Aircraft System, unveiled by the Northrop Grumman for the U.S. Navy. As most people that are familiar with military companies, Northrop Grumman is a private contractor for the U.S. Navy. The UAS will complement the Navy's Maritime Patrol and Reconnaissance Force family of systems delivering SIGINT, signals intelligence, and maritime strike capabilities. So basically, they're saying everything from radar signals to hitting targets by land or ocean. Okay. This right here is getting into the basics of superluminal signals. Basically, some other research that I got into, guys, was basically saying that whether you're talking about sound or light or any type of vibration or wave or permutation in the atmosphere, that scientists have now measured signals faster than the speed of light. So that, pretty much debunks Einstein and Newton. That gets into electromagnetism, and that's a whole nother discussion, so I'll save that for another time. Okay, this right here is it's a program similar to, I don't want to say Photoshop, but it's and I don't want to say AutoCAD, but it's a program where you can use different shapes and angles and beam a light, and it shows you how light would refract through the atmosphere. As you see, as one of their variables here, you can control air, water, glass, and the spectrum of color down to the nanometer. Okay, this right here is going back to this whole article right here is getting into calculus, and it's citing Berkeley going all the way back to 1734, and they were having a whole discussion of what's the proper foundation and structure of calculus. Right here, they're criticizing, or they're saying Berkeley had criticized the use of infinitesimals as being ghosts of departed quantities that are used inconsistently in calculus. Earlier, Newton had defined instantaneous speed as the ratio of an infinitesimally small distance and an infinitesimally small duration. And he and Leibniz produced a system of calculating variable speeds that were fruitful. But nobody in the century or the next could adequately explain what an infinitesimal was. So right here, they're just kind of showing you the history of calculus and some of the problems where they weren't even agreeing in their philosophies what the basic foundation of what calculus was and which data sets they were going to use to um, measure different distances in space. Here again, it's this article's continue on about calculus. Calculus was invented in the late 1600s by Newton and Leibniz. Their calculus is a technique for treating continuous motion as being composed of a infinite number of infinitesimal steps. Okay, this right here, this was an email that I was going back and forth with one of the flat Earth guys in one of the Facebook groups. We were discussing what a hypothesis is, and I'll read the first two here. What a null hypothesis would mean, and if you were to hypothesize if the Earth is flat, then shots taken with the line of sight weapons, meaning non-self self-propelled projectiles, i.e., bullets, will not be limited to the Earth's curvature, bulge, and target hidden amount to effectively engage targets for said distance, elevation, and according to alleged curvature. And then I put another citation here. A lot of guys in the flat earther community were debating with people in the globe community about the line of sight Pythagorean theorem. And one of the websites they were quoting was Metabunk, which was going over curvature calculators, whether you were using calculus or the Pythagorean theorem. Um, so to construct a null hypothesis, you would say if the Earth is flat, then shots taken within the line of sight will not be limited to the Earth curvature, the bulge and target hidden amount to effectively engage targets. So later on, I'll be showing you guys a document about how the Navy's using rail guns and how this would fit into hypothesis about rail guns on Navy ships. Okay, and what would be a alternative hypothesis if you were to say if the Earth is a sphere with a circumference of 24,901 miles, then shots taken with a line of sight weapons will be limited to the Earth's curvature, bulge, and target hidden amount to effectively engage targets for said distance, elevation, according to the alleged curvature. So then again, this would be going back to how the Navy uses rail guns and how they would have to calculate their line of sight. And if you want to get into the arguments about the Pythagorean theorem or calculus, I recommend also starting with Metabunk and just to get a kind of basic foundation of some of these flat curvature, Earth geometric shapes. And then it continues here to falsify the null. If you can't, then you hear that sound. That's your worldview circling down the drain at light speed. So basically, if you cannot falsify the original hypothesis, then you are left with an alternative hypothesis. But if that alternative hypothesis cannot nullify your original hypothesis, then that'll show you kind of where you guys are at with your worldview. Okay, here's another email here. This is about what's the difference between data, and information. So, in other words, for A and B to agree on a code or description, or excuse me, A and B need to agree on a code or description method before communicating. And this is going back to a document I showed you guys earlier, published by Grunwald on algorithmic information theory. And some of the examples here that I put in the email is which of these is information, then, why, or why not. I'm not going to read this whole string here, but these are just various letters that show you that this is just a data string here. Whereas the example number 2, if you say, meet me at Joe's for drinks, that's showing you for data to become information, both parties need to agree on this data set for it to actually be information, intelligible information. So this is where it's saying A and B need to agree on a code or description method before communicating. So as you guys see in the first example, the various letters, it just looks like random data. But if both parties can agree on what letters mean in a data set, it becomes a comprehensible information. So meet me at Joe's for drinks was information versus the first example is just various data. Okay, this right here is a book published in, I believe, I'll look that up for you guys. But it's basically showing how when children are learning about the Earth, how their worldview is formed. So they're getting into kind of child psychology here. So I'll read a little bit of this here. Chapters 1 to 2, language and thought, that the child neither spontaneously seeks nor is able to communicate the whole of his thought. Further, if in the society of other children, the conversation may be associated with this immediate activity or play, thus giving no clue to the essential fragment of his thought which is not concerned with action and which develops by being in touch with various adult activities or with nature. In this case, conceptions of the world and all of physical causality will appear not to interest him at all. So this book is you can find this on Amazon and various PDFs on the internet. This is called The Child's Conception of the World. There's another page from that same book. And then this particular chapter, they're talking about the origin of the sun and the moon and how a child would describe it. Okay, here we go. Corona mission 1005 incident. This incident happened in 1964. And basically, what the Corona program was showing how they were sending satellites up, and what they were doing is they were attaching gondolas. If anyone doesn't know what a gondola is, it's a camera system set up to a balloon. Um, but in this Corona mission, what they were trying to describe is they were saying that they were in the 50s and 60s, they were telling people that they were sending satellites up into space. But once you read this Corona mission incident, I think this gondola had crashed in somewhere in South America, and this was declassified by the CIA. And they're showing how one of these camera systems was attached to a weather balloon. And then another document I have, they're interviewing this guy that was speaking on these gondola cameras that are attached to weather balloons. Okay, let me find another document for you guys here. This is another picture of something I was mentioning earlier when I had brought up the metabunk.org website. And this is another picture of when they're calculating line of sight. You have the viewer height, the horizon distance, the bulge, and what's obscured in the line of sight. Okay, here's another email about information here. Earlier, I brought up what's the difference between data and information. I'll just read a little bit here. This is going further in. Data and information are not equals. For example, data A1, A1, A1. But in order for it to become information, then knowledge, when we set up in advance, prearrange the convention medium of meaning, then agreed, this can only ever be accomplished by intelligent agents. So, in other words, in order for data to be information, it has to be agreed upon, meaning between two parties. Okay, technical memorandum 15689. This was published by David A. Quinet. This came out of the Federal Aviation Administration Inspection Office. And I'll be getting into some of these documents here. If anyone wants to look this up on Google, this publication was titled Validation of the Automatic Flight Inspection Instrument Landing System Best Fit Straight Line Application. Okay, this is going further into the David Quinet cover page I just showed you guys coming out of the Federal Aviation. Okay, and I highlighted some stuff here, and out of this FFA document, so this data was processed using software developed by Ohio University to produce the glide slope error versus keyword versus the distance to threshold results. Figure 1 contains the flowchart for this processing. Okay, and when they're describing this software, it's saying a review of the AFIS software indicated in this initial processing took into account Earth curvature. Further analysis indicated that this error is minor in computing RDH, ARDH. In fact, at 4 miles, the most sensitive location for the RDH calculation, the difference in altitude for Earth curvature versus a flat Earth is 14.10 feet. So just to kind of show you guys some unbiased information, just showing you when they're calculating things, an altitude, Earth curvature versus a flat Earth, that the margin of error is 14.10 feet, according to the FFA. Okay, this right here, this program right here, when they were manufacturing the Deca Navigator system, this was basically the precursor to GPS. I'll read a little bit here. The Deca Navigator system was a hyperbolic radio navigation system which allowed ships and aircraft to determine their position by receiving radio signals from fixed navigational beacons. This system used phase compression of low frequencies from 70 to 129 kilohertz, as opposed to pulse timing systems like G and Loran. This made it much easier to implement the receivers using 1940s electronics. The system was invented in the US, but development was carried out by Deca in the UK. It was first deployed by the Royal Navy during World War II. So if you guys do the wiki search on this, the Deca Navigator system, this is basically the precursor to GPS. Okay, here's another declassified document. Space and Missile Systems Center, Los Angeles Air Force Base. This is the oral history. This is going into the document I had mentioned earlier about the Corona program. They were interviewing a lieutenant colonel about one of these gondola cameras that was attached to a weather balloon. And this is when various agencies such as NASA started selling the story of satellites in outer space. But according to this declassified document, they found one of these gondola cameras attached to a weather balloon that had crashed in South America, and they just recently, within the last 20 years, declassified this document. Right here, I know brother Matthew Craig had mentioned Jack Parsons and JPL Lab out there in California. This is an interesting document that I had found a couple months ago. Um, this is another declassified document from the Department of Defense. This was the Defense Atomic Support Agency. And what this document was basically getting into was telemetry data by the Explorer 4. And what they were doing was they were basically trying to nuke the upper atmosphere. One of the names escapes me right now. I believe his name was, what's that thing that NASA's always talking about when the Van Allen radiation belt. There you go. This document, declassified document right here from the 60s, is gets into a little bit of the Dr. Van Allen about how they were doing nuclear tests in the upper atmosphere um, to see how they could bounce radio signals off the atmosphere, if they could penetrate a hole in the atmosphere, so this declassified document gets into here. This will kind of tie into what Brother Matthew Craig from Black Lotus was saying about the JPL lab and how the military was doing various experiments in the 50s and 60s. So there's just some food for that there. This is just a picture I took off of YouTube where they're talking about the dome being around 250 miles up. Some of the key words when they're talking about um, radars and satellites, and you're seeing all these documents about physics and math and what materials they're using for radars and satellites. Some of the key words are attenuation, refraction, clutter, and noise. And some of these words are kind of relevant because this goes back into some of these declassified documents, such as the one I just showed you in the previous slide, where they're doing these experiments on the upper atmosphere because they wanted to see how the signal would bounce off the ionosphere. So some of these key words are relevant: attenuation, refraction, clutter, and noise. Okay, this right here, I'll have to find this original report for you guys here. I did leave some notes here. This is basically getting into like Doppler radar, and these are some of the math equations that they use for Doppler radars. And I highlighted it a little bit here, and it's saying there are two kinetic effects of rotation represented in the potentials. The first is the Doppler effect produced by the motion of the detector at zero relative to the distant source. The Doppler effect contributes to the factor. The Doppler effect splits the incident wave with frequency into a superposition of waves with frequencies. the component having amplitude proportional. The splitting is unimportant for waves at the 1 Hz band since then. So this, if you guys are interested in Doppler radar technology. Oh, actually, this page was pulled from uh, the Dyson report. Let me look at my notes here, guys. Yeah, so his name was Dyson. Oh, excuse me, guys. Freeman Dyson. I'll be showing that to you guys in another slide. Freeman Dyson, and this is where Freeman Dyson, famous physicist, he was talking about the Doppler effects, which gets into how they use Doppler radar. This right here is coming out. This slide right here is coming out of UC Irvine School of Physical Sciences, and this is just going over the Pythagorean theorem, which I know a lot of times in the flat Earth community are arguing a lot about the Pythagorean theorem in terms of the line of sight when people are looking at objects in the distance, such as ships and other type of experiments that they've quoted from these line of sight tests. A lot of the one of the famous ones that the flat earthers discuss is the Belford Level experiment. So a lot of times they're using Pythagorean theorems, which goes back to Professor Fermat and some of his studies. Okay, this right here is they're discussing where basically where does space start and where does space end. So a lot of times you guys are hearing about NASA talking about the vacuum of space. Okay, well we got to ask, okay, what altitude does our inner terrain atmosphere start and where does outer space start and stop? Because they're always talking about the vacuum of space. So this report is going into basically where's the line of demarcation and basically even up to 2014 they all these scientists are still arguing about where does outer space even begin, what altitude does it begin. This article is coming out of Embry-Riddle Aeronautical University. Here's another report. This is this document is also getting into the cameras attached to weather balloons. I'll be getting that here in a little bit. Okay, here we go. This right here is showing how they shoot lasers up into space and basically how these lasers are made out of sodium and how they're able to see the star so crisp and so clear is they figured out by using sodium in their lasers they are able to get a better reflection in their telescopes because something about the material that they're using, sodium, is able to get better reflective properties. So this is coming out of the Adaptive Optics Facility, Very Large Telescope. And this kind of gets more into how they're using these lasers. Lasers can excite sodium atoms in the mesosphere, which is located 90 to 110 kilometers above the Earth's surface. The fluorescent light that is emitted by the sodium atoms and collected by the telescope has been affected by the atmosphere in the same way as the light emitted by real stars. So the fluorescent light from the sodium atoms can be used by the adaptive optic systems to measure and compensate for the distortions introduced by the atmosphere. Okay, right here. Fact Monster. Uh, this right here, I was getting into a discussion with brother Craig about a month ago. We were discussing the different elevations in America. Um, I think he had mentioned something about California being at a lower elevation. I think it was more towards sea level, and the eastern seaboard being a little bit higher. So that had kind of piqued my interest. So this right here is from a website called Fact Monsters. If you guys want to look at different elevations of different landmarks in the state, you can see what's the highest point and the lowest point, what's sea level, and the elevation of certain mountains. Okay, this right here is getting into something I had brought up earlier. Navy, lasers, railgun, and hypervelocity projectile background and issues for Congress. So basically, this is coming out of the Congressional Research Service. If you guys want to look this up, you could just put this subject into your Google. And this document about lasers and railguns was published by the Congressional Research Service. This is gets going back into Fermat's theorems, which ties in with Pythagoras. If you want to learn more about Fermat and his studies on Pythagoras, these various Greek philosophers, you guys can just type in Fermat and look up some of his theories on Google. Okay, here's another something I pulled out of the Federal Aviation Administration. And this cover page is getting into some diagram pictures, and I highlighted this here. This diagram illustrates this simplified method, and they're using a flat Earth modeling for their diagrams, which are basically showing how the aircrafts use their guidance systems, but they use flat Earth modeling. Going back into guidance, flight guidance systems, here's another document I found. Technical memorandum assessing the validity of using actual navigation performance information for supporting designated flight inspection operations. Okay, here's another document. This, if you guys want to put this into Google, this was kind of a lengthy title. This document was a PDF. I had put into Google distribution to the design of a autonomous guidance law by flatness approach. So I was looking up various information on guidance systems, whether coming out of the military or various academic papers. And in this PDF, they just use nothing but flat Earth modeling. You don't really see too much math based on, spherical geometry in their guidance system planning. Okay, this is how another email. I was having a discussion with someone in my Facebook group. Um, to set up a proper science experiment. This is basically getting into stuff you guys learn in junior high and high school. Independent variables. The independent variables, the proposed calls that you will test to produce the effect. Dependent variable you observed in step one, and It's going on to explain you must have a viable independent variable, no independent variable, no hypothesis, no science. Example one, observe a phenomenon. In the example we were discussing here, sailors appear crippled after long sea journeys. There could be a number of possible causes, but for brevity, we finally realize it's related to diet with poor fruit vegetable intake. This right here is going into someone I brought up earlier in one of the slides I was showing you guys here. This is famous physicist Freeman Dyson. Now, Freeman Dyson was saying that he was born in England and then was a civilian scientist for the Royal Air Force in World War II. He went to Cornell and graduated in 47. And some of the stuff he studied was nuclear reactors, solid state physics, ferromagnetism, astrophysics, and biology. And he had published some math slides I'll get into later, where he's showing guidance systems and going back to modeling. You know, he just uses a lot of flat Earth modeling. He doesn't use too much too much spherical modeling in his papers. Here's a this is coming out of page 530 of his book, of Freeman Dyson. Um, Page 530, and I highlight it here. It was interesting on this page because I just, anytime I see the word flat Earth in some of these uh, publications that these doctors and scientists are publishing, I just go ahead and highlight it. So I want to share this with you guys. What I highlighted here says the flat Earth model is good because the wavelength of seismic waves. This one he was talking about. They're studying like ocean waves, earthquakes, and different properties of light. So it's going on to describe the wavelength of seismic waves, and the 1 hertz band is a few kilometers, small compared with the Earth's radius, and large compared with the size of most surface irregularities. In the millihertz band, the first of these two conditions would fail. In the kilohertz band, the second would fail. The main qualitative result of the calculation is that in an elastic medium, gravitational waves are absorbed only by irregularities of shear wave modules. And it goes on to say the Earth has two major discontinuities, the outer surface and the mantle core interface. Other shear wave irregularities are distributed in an unknown way through the interior. We carry the calculation of seismic response assuming a uniform, homogeneous Earth. It is possible to imagine arrangements of the local topography, so basically the local topography of the Earth, in which a block of the Earth's crust may be seismically isolated by faults from its surroundings, in which a gravitational wave may excite resonant standing vibration. In such a case, the response of a seismometer may exceed or estimate by a large factor, just as the amplitude of an ocean tide may be considerably amplified by local resonance in certain basin and channels. So basically, what Dyson was researching was ocean waves, earthquakes. The only word I don't agree with here is gravitational waves. That's just because I don't agree with the theory of gravity, but I'll save that discussion for another time. But this just kind of shows you where Dyson was studying um, using basically the flat Earth model. Um, but he was still kind of stuck in Newton and Einstein, where he was talking about gravitational waves. Here's another documents, another um, document describing guidance systems that various uh, institutions use, whether it be the military, commercial aviation. And this came out of France by PhD Professor Ali Zoghardi, Dr. Frank Cazorang, and the name of this PDF was Design and Development of Autonomous Guidance Law by Flatness Approach. So here we go again. These French scientists for study of guidance systems, they're basically using flat Earth modeling. And as you see here, application to a atmospheric reentry mission, Vincent Morio. This right here is just getting into the differences in pressure gradients. This is kind of the precursor to another slide about pressure gradients, and it's getting into gas and volume. In the discussion here, we were discussing as we decrease the pressure on gas, the volume increases immediately. Increases entropy. Pressure effects on liquids or solids with respect to volume, hence entropy, are minuscule compared to gases. Water does not move. It is the main reason for currents, i.e. ocean. But as mentioned, pressure effects on liquid solids is minuscule as composed to gases. So this is kind of a precursor to another slide where it gets into basically the vacuum of space and different levels of the atmosphere and allegedly outer space, that you would have different pressure gradients and how this would tie into entropy. And basically entropy gets into how gas, the causality between gas and its different properties of volume, and how that ties in with pressure gradients and any type of atmosphere, whether it's water, air, or any gas constituent. It goes on to say here, my argument is gases with vacuums and non-vacuums, not liquids or solids, in a column. Straw man fallacy. Here's a direct comparison and experiment. Take an empty liter bottle of soda, suck the air out, and replace the cap quickly. And that's how you can see how when you decrease the gas, there's a correlation of volume increasing of a different type. Another picture about solid liquid gas binding. Here's another military application I found. This is basically a recon plane that takes images of the Earth. This is the Global Hawk. It's a high altitude, long endurance unmanned aircraft. RK4 Block 40 Global Hawk. If you guys want to look up the capabilities of that recon plane and what type of pictures of the Earth it can take. This is highlighted out of articles reading about Arthur C. Clarke, and it's basically stating back in the 40s, scientist author Arthur C. Clarke described the best position in outer space for placement of a geosynchronous site. So basically, when NASA was talking about putting satellites in space in the 50s and 60s, a lot of times they were getting inspiration from fiction-based writers or science fiction writers, and that's how a lot of times you hear the expression art imitating life, life imitating art. So when NASA was on their campaign to convince the public of satellite technology, um, one of these science fiction authors had was describing satellites in his fictional based books. It goes on to say he made this prediction in terms of conventional theory of a rotating Earth. Launch a satellite to an orbit that is 21,500 miles above the Earth, so that its motion parallels to a fixed point on Earth, and it can receive and retransmit electrical signals. So this was Arthur C. Clarke. He wasn't even really associated with any military or NASA. He was basically a science fiction writer writing these type of ideas in his science fiction. I won't get into too much of this, but you guys can look up Arthur C. Clarke. Oh, I will get into one argument here. Let me read the bottom here. Here is the Achilles heel of the geostationary Earth theory. If the Earth does not move, then the satellites do not move. If the satellites do not move, then there is no physical force pushing them away from the Earth, centrifugal force to counterbalance the pull of the Earth's gravity. How do they stay up there? So just some more food for that there. Uh, this is getting into more stuff about entropy. I'll get into a little bit here. Um, According to the law of non-contradiction, two things that are contradictory, mutually exclusive, can't be true at the same time. If you have no vacuum, then you have no outer space, has been told by indoctrination for hundreds of years and repeated by NASA and NASA parators for 60 years. What these moonlanders, satellite ISIS people must believe must justify the position of the second law of thermodynamics, their main pillar of science. Law of entropy. Heat flows from hot to cold, always. Energy concentrated to dispersed, always. High pressure to low, always. So, back when I was discussing earlier about vacuums of space, how NASA's saying that outer space is a vacuum, Earth's atmosphere being a non-vacuum, and other publications that different scientists have published about where does outer space start, end, and begin, and how this would have to tie in with the law of entropy, meaning heat flows from hot to cold, energy goes from concentrated to dispersed, meaning spread out, and then pressure has to go from high pressure to low pressure. And the law of entropy, for it to work, would have to somehow work with what they're calling outer space, a vacuum, and inner space, what we would live in, a non-vacuum. So there's kind of some logical fallacies in science with that just don't add up and don't jive with the law of entropy. This right here goes back to a prior email that I was discussing about for data to be tangible, coherent information, both parties need to agree on a description or method before communicating. If you just have random letters, it's just data. If two parties agree on what this data means or these letters mean, then you can have logical communication. This is another picture I pulled from YouTube here in the 50s and 60s when the Navy and various scientists were bouncing radio signals off the atmosphere. They're basically seeing what reactions they were getting off the ionosphere. There's an interesting picture. I just thought this was an interesting picture of the moon up in the upper atmosphere. Another picture of the moon. I believe this was taken from a weather balloon up in the upper atmosphere. This is getting into more physics, math, Stokes theorems, Gauss. I don't really want to get into that. We can save that for another time. This is going into the prior email I showed. How can you have a vacuum of space attached to a non-vacuum Earth and still retain the properties of a vacuum and a non-vacuum in the same system simultaneously? How can you explain this in the law of entropy? If your theory is found to be against the second law of thermodynamics, I give you no hope. There's nothing for your theory but to collapse in the deepest humiliation. That quotation was by Arthur Eddington, The Nature of the Physical World, published. He published this all the way back in 1930, page 74. Okay. This is just an interesting thing I found on Wikipedia about blue ice. Glacial. Blue ice occurs when snow flows on a glacier. When it's compressed and becomes a part of the glacier, air bubbles are squeezed out and ice crystals enlarge, making the ice appear blue. I won't get too much into that, but if you guys are interested about blue ice and how blue ice glaciers are formed, um, and how people have thought it was due to blue light scattering, and this kind of gets into how the air molecules and what's really making this water appear blue. Nice picture of Indonesia. Here's a publication out of Iowa State University. This was published in 1962. The Flat Earth Approximation to the Solution of Electromagnetic Propagation in a Stratified Terrestrial Atmosphere. So basically, this publication out of Iowa State, and again, they're using flat Earth modeling. They're not really using spherical modeling in their studies here at Iowa State. This is going into the same thing about entropy I was telling you guys earlier, a vacuum versus a non-vacuum. This document right here, this is a report that I pulled from a PDF off of Google. And I had typed in the International Terrestrial Reference System. And while scanning through this document, I did find something interesting. When they're talking about the International Reference System, all these scientists are saying that the reference system is saying the Earth is a geocentric, its origin being the center of a mass for the whole Earth, including oceans and the atmosphere. So the reference system, they're including the oceans and the atmosphere. And this is how the system they're modeling they're using for the International Reference System. Just something interesting here. I won't really get into this on this presentation. Jesuit China missions. Another article I found. It was talking about surveying land across the Americas, and in this article, they're basically talking about Kansas. I'll read a little bit here. It says in this article here, materials and methods. We purchased a well-cooked pancake from a local restaurant, the International House of Pancakes, and prepared it for analysis by separating a 2 wide sample strip that had not had time to basically break down. They collected macro pancake topography through digital image processing. And then they took another topographical image using a laser microscope. And then they were comparing it to some of their computer modeling. And when they put this into their software, they measured a west to east profile across Kansas, taken from merged 1 to 250,000 scale digital elevation model data from the United States Geological Survey. And basically, what they found is Kansas was flat as a pancake. Oh, this right here is getting into pressure gradients that I brought up earlier. And what we're discussing and some of the articles we were reading on the internet, it was saying the pressure gradient at sea level from the atmosphere is 760 torr. The pressure gradient in which turbojets no longer function is 8 torr. The pressure gradient for the U.S. definition of spaceflight is 10 to the negative 3 torr. The pressure gradient for low Earth orbit atmosphere pressure is 10 to the negative 9th torr. They're stating that the moon pressure is 10 to the negative 12 torr, and interstellar deep space is 10 to the negative 17 torr. So basically, they're saying the vacuum of space, the pressure gradient is 10 to the negative 17th torr. Here's another document about debunking Einstein's theory of relativity. Because this recently, just in the last 15, 20 years, they've done studies where they've done data pulses in a lab, and these data is moving faster at the so-called speed of light, which in some other research I'll show you guys later, there really is no such thing as the speed of light, because light is not a thing. It's not a tangible thing. It's just a vibration in the atmosphere, whether you're talking about light, sound, um, and it's not something you can quantify as the speed, because even if you were to take light or sound and glass, as soon as you move it from a medium, it goes back to a whatever speed it wants. It's not limited to the medium that it's in, and it's not a tangible thing. It's just a vibration in a field. What Tesla was calling the ether is just really describing field dynamics. So there really is not even a such thing as the speed of light, but I'll say that for another discussion. This is coming out of LIGO. I know in the last year, a lot of you guys are seeing stuff about LIGO, observation of gravitational rays from a binary black hole. And a lot of people, I know you guys are probably seeing on YouTube, a lot of people in the flat Earth community have debunked this, about gravitational waves, or what they were seeing was just a couple seconds of magnetic patterns under a microscope, and they were just calling that gravity to fit into their presupposition. And I just wanted to show you this, guys, about LIGO. We can get more into that later. This goes more into LIGO, how they're setting up their various mirrors and beam splitters. Idealized Michelson interferometer with laser beam splitter and mirrors. This is coming out of the ESA website, LISA Assessment Study Report. This is going right back to the gravitational waves that they're saying that they so-called discovered gravitational waves, but they're not really telling you. What they're really observing is this magnetic uh, wave pulses under a microscope, and they're just calling it gravity. Let me go back one, guys. Um, well, I can't seem to go back to it now, but the prior slide was a showing of different satellite missions dating back to the 50s. Hold on, give me 1 second, guys. Oh, maybe I can go back to it. Okay, I'm sorry, not satellites. These are right here, a list of all balloon launches from the Strange Space Center. Strange Space Center. This is, I think, believe that Space Center is located in Switzerland. If you guys want to look up a list of all their balloon launches, they have a PDF on their website of the year and the date of all their balloon launches coming out of Switzerland. Okay, this publication is coming out of Lockheed Martin, and this one, unfortunately, you cannot get the PDF for free on Google. You have to purchase this from one of the scientist database websites. I think you have to pay a few dollars. And basically, this is a numerical study of a three-dimensional flow separation for a ellipsoid. Basically, Lockheed Martin is studying their guidance systems for their planes, satellites, balloons, whatever you guys want to believe, and some of the math that they're using for their Lockheed applications. They're describing the Earth as being an ellipsoid. Another document about tying in with what another slide I was showing you guys earlier. Loran ties in with Decca. This is the precursor to GPS. This is a document about lunar ranging, and they're getting into some of Newton's theory. Um, we can go over. We can skip that for now. Um, let's get into the difference between physics and math. Okay. What I highlighted here is math isn't science. Physics, much like a tape measure, isn't carpentry. One of the main reasons is their different words. Math is immaterial, abstract, often rigidly domain specific, and at best merely describes. It explains exactly nada. Conversely, actual scientists are in the business explaining by validating or invalidating cause and effect, relationships between independent variables via rigorous hypothesis testing. That's the whole point about physics. It's not mathematics. So, I mean, you guys know it's a lot of physics uses math, but one of the problems with math is it's totally abstract. They're just trying to quantify something, and it depends on the domain, and it can only describe. It's not really validating cause and effect. It can only describe. A lot of times, even just their preconceived theories. Here's a wiki entry I found. Max Planck Society. I know you guys have probably heard of Planck in a lot of your physics classes. I'll just read a little bit here. The Max Planck Society for the Advancement of Science is a formally independent, non-governmental, non-profit association of German research institutions founded in 1911 as the Kaiser Wilhelm Society. Uh, this is actually coming from the metabunk.org website. I believe it was Young Pharaoh, or Q Butter had talked about this Metabunk site, and this just gets into their curvature calculators of people arguing the line of sight and where's the horizon, the bulge, and atmospheric refraction. So if you guys want to check out Metabunk and these various curvature calculators, you guys can check out that website. It's a good data feed. Here's a picture I found. I believe this is a missile that they had shot up into the atmosphere. So I just thought it was an interesting picture I want to show you guys. Here's another document published by Neil Palumo and Justin Lloyd. And this other guy, Ross Blaukamp. And this is also getting into guidance systems. This one is a PDF I found online. This was titled Modern Homing Missile Guidance Theory and Techniques. Here's another PDF I found online by Lee and Lil. I think I brought this up in another slide. I believe this is the first page of that slide. Motion of a sphere in the presence of a plane interface. So that's an interesting read if you guys want to look at the fluid-fluid interface and how they're describing what a sphere, flat terrain would look like, and how fluid parabolics work in that terrain. Okay, this was coming out of, let me look at my notes here. This was a declassified NASA document, NASA report 1207. This is page 30 of that report. And it was interesting, I noticed in their concluding remarks, I highlight it here as I'm going over my notes. It says, in this report, derives and defines a set of linearized system matrices for a rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth, both generalized and standard linear system equations and derived from non-linear sixth degree of freedom equations of motion and a large collection of non-linear observation measurement equations. So this was basically their concluding remarks coming out of a declassified NASA document. So it's just kind of funny in their concluding remarks how they're talking about a flat, non-rotating Earth. Another NASA document, Contractor Report 4667, Optimal Guidance Law Development for an Advanced Launch System. Another NASA, well, nope, this is a same report, NASA Publication 1207, Derivation and Definition of a Linear Aircraft Model. This is from the National Technical Reports Server. It was also interesting to see their study here, a comparative study of a spherical and flat Earth geopotential modeling at satellite elevations. This report here, this is getting into, this came out of the National Geospatial Agency. If you guys could just do a wiki on that, National Geospatial Agency. And this is kind of going over some of their ellipsoid math. They're describing the Earth as an ellipsoid surface with reference points of A, B, then closed mass, and what the angular velocity is according to their Stokes theorems. And they get it, and when they're describing the Earth as an ellipsoid, a lot of times they'll use this gravitational constant because they're stuck on this Newton and Einstein particle materialism type physics. Another email's going over with the guy in my Facebook group. Naval gunfire. This gets into the rail guns that the Navy uses. And we had highlighted that the naval, basically the railguns, has a flat trajectory that makes them effective against vertical phase targets, but ineffective against rear slope targets. And indirect fire weapon artillery uses high explosive rounds. The Navy railgun uses projectile. It is non-explosive, and it does all of its damage due to speed. But the thing about the Navy railgun is it has to use flat Earth trajectory for its modeling. Um, it can't really do slope targeting too effectively. Using an indirect fire weapon, the projectile will lose most of its speed and drop at a piece of dead 25 pounds hunk of metal from the sky. There's another document. This is coming out of the Naval Postgraduate School, Monterey, California. And their thesis, they're getting into a study into the advanced guidance laws using computational methods. And when you read this report, you'll see whether how much they're using flat Earth modeling versus how much they're focusing on spherical modeling and their theories and math. This is going over some of Newton's theories. This one, it's not really important. I'll just skip that one for now. This right here is the National Geospatial Intelligence Agency. And basically, agency does a lot of the mapping of the Earth terrain. So if you guys want to look that up, this military contractor is called the National Geospatial Intelligence Agency. So they probably have a lot of recon images from these recon planes, such as the U-2. The wiki entry, National Geospatial Intelligence Agency, is getting into the history of the National Geospatial Agency. Here's a quote by Friedrich Nietzsche I found interesting. And it states here, the individual himself is a fallacy. Everything which happens in us is in itself something else which we do not know. The individual is merely a sum of consciousness, feelings, and judgments and misconceptions, a belief, a piece of the true life system, or many pieces thought together and spun together, a unity that doesn't hold together. We're buds on a single tree. What do we know about what can become of us from the interest of the tree? But we have a consciousness as though we would and should be everything, a fantasy of I and not and all, not I. Stop feeling oneself as the fantastic ego. Learn gradually to discard the supposed individual. Discover the fallacies of the ego. Recognize egoism as a fallacy. The opposite is not to be understood as altruism. This would be love of other supposed individuals. No, get beyond myself and yourself. Experience cosmically. And another quote by Nietzsche. It states, one might invent such a fable and still not have illustrated sufficiently how wretched, how shadowy, and flighty, how aimless and arbitrary the human intellect appears in nature. There have been eternities in which it did not exist, and what is not done for again, nothing will have happened. For this intellect has no further mission that would lead beyond human life. It is human rather, and only its owner and producers give it such importance as if the world pivoted around it. But if we could communicate with the mosquito, then we would learn that it floats through the air with the same self-importance, feeling within itself, flying within the center of the world. Um, Here's another page out of the NASA report 4667. I showed you a couple other pages from the same report earlier. NASA report 4667, another page that I highlighted here. I highlighted where it said non-rotating Earth. The Earth's rotation is small, and the term which represents the transport acceleration was neglected. The term I'm not going to read all that, guys. The term which represents the Coriolis acceleration may reach zero point 0.1 g at orbital speed. Here, g is the gravitational acceleration at the Earth's surface. However, the vehicle reaches orbital speed sharply near the end of its flight phase. Therefore, the dominant effect on this term is only apparent for a short period of time. The setting gravitational constant acceleration at zero does not produce any significant error. So basically, they're showing in their equations here how their magnetic acceleration, how it correlates to a non-rotating Earth. Here's a wiki entry from Northrop Grumman, another military contractor, showing you another one of their recon planes. This one's the B-2 Spirit. This report is coming out of the National Reconnaissance Office. And in this report, published July 2015, they're talking about how their telescopes are designed. And it goes on to state that the telescope must operate over wide slant range excursions. These changes in range result in a shift in the location of the objective lens focal plane. For the present optical design, the focal plane shift as a function of roll and pitch angles are depicted in figures 1.5. The defocus values in the figures are predicted on the following assumptions. Here's another wiki entry, family. This is talking about Operation Fishbowl. And Operation Fishbowl, they're showing how the nuclear tests were originally planned to be completed during the first half of 1962. The three tests named Bluegill, Starfish, and Eureka. And basically, in these test guys, they're basically trying to blow holes in the atmosphere. So I think Mr. Craig had stated he's going to go over some JPL information that relates to Jack Parsons and a lot of these occultists that were interested in these type of experiments. This report was published by, I believe, some Russians stating, I'm not going to try to pronounce that, 1970, Alexei and Guskov, 1970, 1976, and they were studying gravity waves on the ocean surface. And some of the stuff I highlighted here was in the paper, we derived the equations and boundary conditions governing the tsunami mode of a flat, uniform depth ocean overlying an elastic isotropic solid Earth, with elastic parameters and density varying only within depth. And although the works were cited are all based on flat Earth models, none make reference to the tsunami normal mode of a flat ocean Earth system. But in the context of a spherically symmetric ocean Earth model, you formulate the equations of motions in a manner originally applied to Earth's free oscillations. This report goes on to state on how they're measuring it on a spherical rather than a flight surface. So, I mean, this is to go, you guys. I'm not just trying to look for flat Earth documents or geospace or guided system documents that cite flat Earth. Here's a report coming from some Russian where they're studying tsunamis, and some of their modeling was based on spherical modeling. So, when you're researching this type of stuff, you can't be biased. Here's a report coming out of Emory University. Embry-Riddle, if you guys want to type in Embry-Riddle University, here's where they're studying some NASA aviation, and I'll highlight it here. There is no consensus over what constitutes the deviation between Earth's atmosphere and beyond. So basically, Earth's inner sphere and so-called outer space. Section 103 of the NASA Authorization Act of 1958 defined the term aeronautical and space activities as research into the solution of problems of flight within and outside of Earth's atmosphere. This is page 3 of the document that the Russians were discussing about tsunamis and how they were using spherical modeling for their oceanic studies. It's page 4 of the tsunami report. This is page 8 of the Corona program. This is the document I was showing you guys from the CIA declassified Corona program, where in the late 50s, I believe it was around 1958, a weather balloon gondola, basically a camera attached to a weather balloon, had crashed in South America. And they were interviewing this lieutenant colonel about this gondola that crashed. This is a CIA declassified document. This right here is page 12 of the Iowa study. I was showing you guys earlier about the Iowa study, and in page 12, they state, at this point of the flat Earth approximation will be made. The flat Earth approximation is a transformation from spherical polar coordinates to cylindrical coordinates. After the transformation has been made, the two one-dimensional differential equations will be solved. The Hertz vector will be found by weighting each term of the complete orthonormal set of solutions in one variable by an appropriate Green's function to the other variable. This is page 12 of the NASA 467 report. Not really going to go over that right now. This is page 13 of that same 467 NASA report. It stated recently Philly and Speyer have used regular perturbations on the expansion of Hamilton-Jacobi-Bellman equation and have applied it to the launch vehicle guidance problem for exo-atmospheric flight. The approach requires an analytic zero solution and quadrature evaluation. The analytic solution is again based on a flat Earth, no atmosphere approximation, and the neglected dynamics are introduced as perturbations. Here's page 14 on that same NASA report 4667. It states in the report organization subchapter, the second is a regular perturbation approach based on a zero order solution for a flat Earth, no atmosphere assumption. Section 4 details the development of a hybrid approach that employs both regular perturbation analysis and the method of collection. This is page 17 of that same Corona CIA declassified document by Lieutenant Colonel, where he's talking about the gondola camera crashing in South America. This is page 18 of that NASA report 4667, where they're showing the reference points of Earth in a fixed reference system and their coordinate systems that they're using. This is page 23 of that same Iowa study. And in section E, the flat Earth approximation, this is the Earth flattening approximation is nothing more than a transformation from a spherical polar geometry to a cylindrical geometry. Transformation equations are as follows. And in the bottom paragraph, it states the transformation is such that a cone with its apex at the Earth's center becomes a cylinder, and the surface of the Earth becomes a plane oriented such that the axis of the cylinder is normal to the surface of the plane. This is coming out of page 26. This is getting into cameras. I was having a discussion a few months ago with brother Matthew Craig about camera systems that private contractors and certain contractors are using. And this actual report came out of the National Reconnaissance Office. And if you guys want to type this in, this is analysis of the image motions in a camera having forward and side rotations. And in this National Recon Office document that was declassified, it says that envision a camera system oriented as shown in figure B1 with a Cartesian coordinate system whose XY plane defines the ground plane for a flat Earth. Let the origin be fixed in the neutral point of the camera whose focal length is F. And for G, part of their equation says the vector from the camera neutral point to any ground point on a flat Earth. So is this interesting how they're describing this stuff for their camera studies coming out of the National Recon Office? This is coming out of page 30 of the Naval Postgraduate School. I showed you guys a cover page for the Naval Postgraduate School earlier. This is page 30 out of that report. This is for this simulation, flat Earth approximations are used as the ranges involved in air-to-air combat are relatively short as compared to tactical ballistic missiles, and a point mass model will be assumed for the flight dynamics. The following vector equations fully describe the motion dynamics of a free body in space. Okay, here's page 43 of that same NASA 4667 report. Okay, it states in their launch vehicle applications, it states the following. Assuming that the dominant forces on the launch vehicle are thrust and gravity, an attempt is made to treat the atmospheric effects as a perturbation effect. To further simplify the problem, spherical Earth effects are also considered as perturbations. These effects are only apparent when the vehicle reaches orbital speed near the end of the flight. The result is similar to the maximum horizontal speed transfer problem in citation illustration 33 for a flat Earth non-atmospheric situation. So again, here's another NASA report describing how they're using flat Earth modeling. But they're telling that us, showing all these images of the Earth being a globe, and but a lot, if you really dig into a lot of their or to some of their papers, such as here in NASA report 4667, that's declassified. They're using flat Earth modeling, guys. They're not using globe Earth or spherical Earth modeling and some of these reports. Okay, here's another thing that I highlighted out of Freeman Dyson's book. That's the Cornell physicist that I showed you his guy's bio earlier. And on page 530, page 536 of Freeman Dyson's book, he states the following. This is an approximation to consider the Earth flat. A uniform sphere model would have no advantage over the much simpler flat Earth model. In this section, we calculate the seismic response to a gravitational wave on a spherical rotating Earth, assuming that the local dynamics is described at the flat Earth equations. We considered only the kinetical effects of sphericity and rotation produced by the motion of the source relative to an earthbound detector. The effects of rotation would be qualitative similarly if we replace the flat Earth model by a more exact dynamical theory. Main features of the rotation effects arise from purely group theoretical considerations. So even here, Freeman Dyson, you see he's trying not to be biased. He's showing you what rotation and the spherical modeling will look like and how he would compare it to flat Earth modeling. But he admits in this one of these last sentences here that the main features of rotation effects arise from purely theoretical consideration. So, guys, when you guys are reading through a lot of these theoretical papers, you got to read between the lines, and when they're doing comparative studies of their different modeling and theories, that they don't really know. They just throw out a lot of assumptions and presumptions. And I'll finish with this on Freeman Dyson on the Earth's surface, rotating with the Earth at being vertically downward, horizontal north, horizontal east. This is going right back to what I began with in the beginning of the program about Fermat's theorem and the history of calculus and how they're describing physical space and infinitesimal points, and how when they were coming up with the philosophy of calculus, how even to this day they can't even really agree on their coordinate systems, um, infinitesimal points, and how they should do their standard models and solutions for calculus. It's still an ongoing debate about how they even do calculus. And this is, if you guys kind of want to read more into this, just look up Zeno's paradox or Zeno's paradox standard solutions of calculus, and you'll kind of get into the history of calculus. Okay, here's another email from I was going over with the guy in my Facebook group. Um, what we're discussing here is rotational frames of reference. And the assumption was here, if the rotational frame of reference of the Earth is 1,000 miles per hour to the plane speed, let's assume the plane is going 500 miles per hour, and the Earth is rotating 1,000 miles per hour. If you add those together, you would have 1,500 miles per hour. And in the example here, we were discussing, say, if you were to take a eastbound flight from LA to New York, will immediately slip out of the rotational frame of reference upon takeoff, climbing to cruising altitude. And at the same 500 miles per hour, which has to be subtracted from the rotational frame of reference, since that's the same direction, 1,000 miles per hour, Earth's rotational speed being 1,000 miles per hour, Earth's rotational speed. However, the plane speed being 500 miles per hour. We will not only conceptually take 3 times as long, but practically in reality never catch up to the destination yard before it gets bum rushed by said destination at 500 miles per hour. If you say the 1,000-mile-per-hour initial spin momentum of the Earth resolves thing, what if the LA runway is facing west and the plane takes off in a westerly direction, then turns east? Where did this alleged 1,000-mile-per-hour momentum go? So, just some food for thought. I mean, if you guys have ever flown, I mean, how is it that saying that the planes are going at a certain speed, and allegedly the Earth is rotating at a certain speed, but how we would land on the Earth, it just on the runway, it just doesn't add up, guys. Here's the website if you guys want to look up. I would put into your Google Project Loon. If you guys want to look into Project Loon, are basically describing balloon powered internet for everyone, which is just basically a form of Wi-Fi using balloons. But when I was looking at this stuff about Google coming out with Project Loon and all these Wi-Fi projects using balloons, I'm asking, okay, if there's if NASA and all these private contractors, military contractors are saying they have satellites for everything, why would you even need to use balloons for Wi-Fi? It just doesn't make sense why they would need to invest in balloon internet when supposedly satellites can take care of, you know, Wi-Fi for everything. Okay, this is coming out of page 10 of that Iowa study. This is going on describing propagation in atmosphere. I'll just read a little bit here. It says the article by Pierce is the basis of the present analysis since the Earth flattening transformation and the airy integral solution with its rapidly convergent asymmetric expansion is a very attractive technique. These slides are just about quantum physics, which a lot of the stuff about quantum I don't agree with. Quantum just means to quantify. Anything dealing with like physical atoms, electrons, protons, quantum, Newton, Einstein. I've just done too much research on that stuff into material physics, and a lot of it can be debunked, but we'll save that for another discussion. Decoy state quantum key distribution. Okay, right here, this is a visual illustration of the Navy railgun. And as you see here, it's talking about their ballistic trajectories. So if you guys want to look into this, I got this off of the NavyWeps.com. If you guys want the link, I can send that to you. This is the illustration of their how they're doing their GPS tracking for their jamming and different projectiles and missiles. All types of naval weapons, not just railguns, but missile technology and what their capabilities are. In the email here, we were discussing from the Facebook group about the railgun, and in here off this internet article, www.dailytech.com, it's talking about the Navy railgun, and Dr. Roger McGinnis is an executive in the railgun program. He said the weapon does all of its damage because of its speed. An indirect fire weapon, artillery uses high explosive. The Navy railgun projectile is non-explosive. It does all of its damage due to speed. As an indirect fire weapon, it will lose a ton of speed and just plop a piece of dead weight. So this emails is kind of going over the difference between the projectile that a railgun uses versus how gunpowder explosive works. And the reason the Navy uses this is because no gunpowder. They don't need to use any type of gunpowder, chemical propellants, eliminating the need to carry dangerous explosives on board. In this email, we just continue the discussion that the railgun has a range. What they're shooting out of the railgun has a range of 125 miles. This website here has come from the Armed with Science official U.S. Defense Department science blog, and this is describing how the railgun works. Next phase of the railgun prototype to test in 2016. And as I discussed earlier, the only way these railguns could work with the line of sight using flat Earth modeling, because the way these projectiles work, it would be hard to use any type of spherical or curvature math. They're not really good for slope targets. They generally use missiles and missile guidance systems and different types of weapons for stuff that requires calculus and hitting targets more, where they're having to shoot up missiles up at a curvature up into the atmosphere. This is more stuff about another the document I quoted in the beginning of the program. by S.H. Lee and L.G. Lill, and page 722, rotation of a sphere in the presence of an interface. I highlight it here. Finally, we turn to the case of a stationary sphere rotating with a constant angular velocity in the presence of a plane interface. Um, it goes over a lot of equations here. If you guys are interested, this is just a publication by Dr. Lee and Lill. We're just describing the rotation of a sphere, and they have a lot of equations here. But for brevity of time, I'll just go on to the next slide, and if you guys are interested to look that up, I can send you a link for that. Okay, this right here I pulled from Wikipedia, and it's describing the Sagnac effect. The states in the Sagnac effect, also calls the Sagnac interface, named after French physicist Georges Sagnac, is a phenomenon encountered in interferometry that is elicited by rotation. The Sagnac effect manifests itself in a setup called a ring interferometer. A beam of light is split into two beams and are made to follow the same path, but in opposite directions. So, um, what got me interested in this is I don't agree with the speed of light, but I did find it interesting how in these experiments how they're um, when they were splitting these beams, how they were measuring their frame of references, and I just I just found it interesting. Um, they were just showing how when they split up this beam that it would hit the mirror at different time intervals. I won't spend too much time on that, but I just thought that experiment was interesting. If you want to look that up, the Sagnac effect. This is a report out of Sandia. They're a military contractor. This is just talking about nanorobotics. This is the cover for the book the guy talked about, Dr. Freeman Dyson out of Cornell. This is the selected papers of Freeman Dyson. A lot of those pages I was reading out of from Freeman Dyson. This is his book right here that was quoting his uh, quoting his material out of. Another thing from if you guys want to look up a lot of these science articles, it's pulling a lot of these from Semantic Scholar. This is talking about superluminous signals and engineers' perspective. Um, so what some of these studies that these scientists are doing is they're finding when they're doing these uh, pulsating these signals, they're finding that it goes faster than Einstein's quote unquote speed of light. So this kind of debunks a lot of Einstein's research. Let me read you another email from my buddy from Facebook. Um, this is kind of going into the example I gave earlier about the difference between data and information. And I wrote here, information software is semiotic. It is not physical material or physically a part of the medium of conveyance. Letters, numbers, symbols are just prearranged conventions between the transmitter and receiver for communicating and to understand the message. So, the example here is software is the meaning, the code is the symbols that represent the agreed upon meaning. See this cat? This is code for what? Um, Here's a picture I took off of YouTube. If you guys want to look this up, type in sonoluminescence into YouTube. SOMOLUMINESCENS, sound creating light. and they got some YouTube videos where they're showing how using sound vibration and water, different chemicals in a glass, how they were able to create light out of sound vibrations. Here's another picture of the flask that they use to create light out of sound vibration. Which, I mean, the light that it produced, it looked like stars that you see up in the upper atmosphere. Here's a picture. I just found this on Google. They were just showing all these what would look like all these alleged satellites in space. This article about space debris, and it's just kind of comical that they supposedly have all this satellites, as you see, like hundreds and hundreds of satellites in outer space, but yet, we don't ever really see these satellites falling to Earth. Um, So-called meteorites, they're not hitting all these satellites, but yet, some of these space articles, they talk about all these satellites up there and space debris, and supposedly these meteorites never hit them, these asteroids never hit them. A lot of these satellites aren't falling to Earth, so I just always found that kind of contradictory and laughable. Here's a report about space radiation. That was another question I had: is if they're saying that they're sending astronauts to the moon, and somehow back in the 60s they made it past the Van Allen radiation belt, and now they're saying that they can't go back to the moon because of this radiation belt, and somehow they can't do something now that they're able to do 50 years later, and they never really described to you guys how these astronauts are able to handle all this so-called space radiation. Another page out of Lee and Lil. This is page 706. Not going to read all this. This is just more about parabolics, liquid interface, parabolics, axis of rotations in relation to a plane, how you would describe the Earth as a plane. This is the picture of superfluid helium. And another page out of the superluminal sound studies, how they send pulse, and how they were saying in a lab they've been able to send sound perturbations faster than the speed of light. Another report. This is out of Vienna, Austria. Superluminal signals and engineer's perspective. Guy that published this, Thilo Salter, out of the physics department. This is another entry you guys can put into Google. Tangent steering for a flat Earth, and in this report, in section 1, I saw they had for a flat Earth, the bilinear tangent steering law representing a reference for a flat Earth in the form, and here they give the equation in illustration number 21. This is that same report, derivation of linear tangent steering law. So they're using these type of studies for their guidance systems, military guidance systems for planes, missiles, GPS. As you see, this was prepared by Frank M. Perkins, Guidance and Control Subdivision, Aerospace Corporation. Here's a quote by Tesla. Today, scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. Here's a picture from YouTube. NASA testing signal return bound speeds from the dome. Here's another private contractor, Balloon, another company launching balloons. And I believe this company, they actually offer private balloon flights for private citizens. You guys want to look into taking a balloon flight like Winnie the Pooh. Uh, Another email about what we discussed earlier about what is information exactly. And it states in order to have information, for example, meet me at Joe's for drinks. What's the difference? Well, we both agree on the cipher, median convention meaning of one beforehand. The cipher is every fourth letter. Up above in that email I showed you earlier, it just had random letters, which is this data, but in order for it to have meaning and information, you have to have the two parties agree. But in that data, there was actually a cipher. Every fourth letter contained that code, meet me at Joe's for drinks. For information to exist, you not only need a transmitter, but a receiver, but they need to agree beforehand on the medium, meaning, and convention. Here's a report talking about the detection of ether. Um, this is this Webster Kerr. He's kind of studying up on Tesla's information about ether, but as I studied more about ether, I just realized it was just the study of fields, basically how magnetism works and um, the nature of fields. Some more papers about Gauss and Stokes theorems. Here's a report. Physical Review Letters, published 1982, Experimental Realization of Einstein, Rosenbaum. Not going to really get into that right now. Another email about the Navy railgun, which I discussed earlier, has a range of 125 miles. This report is just talking about the science of parabolic flows and fluids. Gets into Stokes equations. Here's an email about we were discussing the so-called theory of the vacuum of space, and an example we were talking about here: take an empty liter of a bottle of soda, suck the air out, and replace the cap quickly. This goes into the law of entropy, one of Newton's theorems. Ensure the sides of the container are somewhat collapsed, denotating a very minor vacuum. Pound a 3-inch nail through the small sheet of a 1/4 inch plywood and lay the board flat on the ground. Put it up against alleged strong gravity. With the business side of the nail in the vertical position, puncture the bottom of the bottle with the nail and tell us what happens. Now for my claim. Flip the script where you have exponentially stronger vacuum with the exponentially weaker gravity. What do you suppose will happen? This is describing the law of entropy. High pressure to low pressure, concentrated atmosphere going into more dispersed. And this the contradictions of this. How could outer space be a vacuum, be connected to a weaker pressure gradient, meaning our atmosphere, and we're not being sucked up into outer space? This article is just describing the weird ways of superfluid helium. If you guys want to look up superfluid helium, I don't agree about the quantum effects. A lot of that's just getting into materialism, atoms, particles, a lot of Newtonian BS. But it's interesting when you look up superfluid helium on YouTube how um, these helium bubbles just kind of float all over the place. But that's really due to what they're calling gravity effects is really due to differences of density and buoyancy between different chemicals. I thought this quote was interesting. Email we were discussing Richard Feynman, and Richard Feynman said there's no model theory of gravitation today other than in mathematical form. So Richard Feynman here, he's admitting that gravity is only described in mathematical form. And as we discussed earlier, mathematics is just a abstract model to quantify something. It's not uh, a tangible thing in reality. Here's one of the physicists I showed you guys one of his papers earlier. This is Thilo Soller. This is his bio on the Austria section website. This paper right here, this is one of the superluminal signals papers. And I mean, if you guys go over this whole paper, reading all these superluminal signal reports, just this paper right here that I'm showing you, I mean, it just totally debunks Einstein's speed of light. This slide right here, another guidance missile guidance system report showing how the Tomahawk uh, land attack cruise missile works. And if you read through the report about the Tomahawk missile, they use a lot of flat Earth modeling, even in their guidance systems. This is another page from the Tomahawk missile report. I highlighted here the inputs for the trams include a functional description of the radar system, the radar cross section of the Tomahawk, initial atmospheric conditions. Tomahawk trajectories are typically represented as a set of straight and level flight profiles, each at a different altitudes over flat terrain. So, I mean, a lot of the stuff I'm showing you guys is coming out of not just universities and academia. A lot of this flat Earth modeling is coming out of military reports. I remember one of the brothers in the conscious community, Q Butter. I'll give him some free advertising today. Um, he had said that something to the effect that the military doesn't have any studies on flat Earth modeling, or something about the military doesn't use any type of flat Earth math or flat Earth analytics or modeling in their science. So maybe this is something that Q Butter needs to look into. Here's another report published by Robert P. Comer. This report is going over the tsunami mode of a flat Earth and its excitation by earthquake sources. The summary, the abstract here, the tsunami generation by earthquakes in a flat, isotropic, elastic, vertically stratified Earth underlying a uniform depth, incomprehensible ocean can be studied in terms of the tsunami normal mode of the combined ocean solid Earth system. So I thought that abstract was kind of interesting. Here's a image of one of the recon planes. This is the U-2 Dragon Lady. You guys want to look up some of these recon planes? This report is United Nations Office for Outer Space Affairs, and if you read this UN website, it shows everything that NASA and everything that they have alleged that they've sent into space, whether they've been, you know, rockets, balloons. And let me go back to the prior slide for a second. The reason I'm showing you guys a lot of these stuff about these recon planes is these recon planes, they're giving you a more accurate depiction of the terrain of Earth. So whatever images they do give you from these uh, recon planes. I just found the images of the terrain just more reliable and trustworthy. NASA, they kind of use a lot of composite images that they merge together. Um, but I think more of the honest images of the Earth terrain are probably coming from these recon planes taking pictures of the terrain versus these pictures that NASA's giving us of these globes. They've even admitted in a lot of their source material that they're just composite images. Here's a report. Came out a couple years ago. This article stating the U.S. Air Force wants to plasma bomb the sky using tiny satellites. Um, so I thought that was interesting about the Air Force wanting to plasma bomb. This kind of gets into some of the stuff that was going on in the 50s and 60s with Van Allen and the report I showed you in the beginning of the program about the CIA showing how they were bombing the upper atmosphere. For example, Operation Fishbowl and a lot of their programs that have been declassified now, and how Jack Parsons was interested in a lot of these type of studies. This article is talking about how they're wanting to use tiny satellites. I'm not sure how they would use satellites. Maybe they would use some type of missile or HARP technology. I'm just not sure about the satellite. I just kind of think that's a little bit of disinfo. Um, this right here is a report. One of the DoD reports, subcategory World Geodetic System, published 1984, and it's just showing you a lot of their flat Earth modeling that the DoD was using for their World Geodetic Systems 1984 reports. You see some of their parameters: semi-major axis, parameter flattening factor of the Earth, and parameter nominal mean angular velocity of the Earth, and geocentric gravitational constant. So this is a lot of their abstract math that they're using for their modeling, whether they're trying to describe the flat Earth terrain, or even if they're biased towards a globe Earth or Earth curvature. This is kind of covers a lot of their equations and parameters that they're using, that the DoD is using. There's another page out of the World Guidance System DoD report. It's describing the Earth as an ellipsoid. Section 301. In geodetic applications, 3 different surfaces or Earth figures are normally involved. In addition to the Earth's natural or physical surface, these include geometric or mathematical reference surface, the ellipsoid, and equipotential surface called the geoid. Chapter 6. Another page out of the World Geodetic System, 1984. This is one of the cover pages. It says Earth Center, Earth Fixed Terrestrial Reference System, and Geodetic Datum. Here's another email. We were talking about entropy and what causes gravity and mass. If the universe is infinite, how do atoms assemble on at least one planet and around at least one star into beings able to ponder these mysteries? These questions still baffle us. This slide is talking about proper research, um, the difference between scholarly and non-scholarly articles. Another article about where does outer space begin? Or in other words, what's the demarcation between inner space or atmosphere and outer space? To this day, they still can't agree where that line of demarcation starts. An email, we were discussing the same thing about these articles. There's no physical barrier between Earth's atmosphere and space, which there isn't. One of the articles from ABC.net, so one of the science articles, there's no clear boundary between Earth's atmosphere and space, says Dr. Kevin Plimbler. One of the other articles, there's no different boundary between the atmosphere and outer space. So I just concluded here. How can you have a vacuum space attached to a non-vacuum Earth and still retain properties of a vacuum and a non-vacuum in the same system simultaneously? Then again, guys, this violates Newton's law of thermodynamics. Another picture of this is off NASA. This is showing one of their images of their coordinate systems of how they're alleging the ISS space station is up there. And let me go back to that. This one also came out of a report about the camera, the articles I was showing you about the camera systems. Another article about the plan to launch giant Wi-Fi balloons over Puerto Rico. Project Loon. I know you guys have seen a lot of these articles about them attaching Wi-Fi to the weather balloons, but then again, my question is, why would they need to do this if we can get all of our signals from all these so-called satellites in outer space? Why would they need to launch a Wi-Fi balloon over Puerto Rico? Another report about superluminal signals, more stuff about debunking Einstein's theory of relativity, speed of light, things of that nature. Another, here's another slide about LISA. You guys are hearing about these articles about they discover gravitational waves. Just some notes about how to construct a hypothesis. And in order to set up a proper experiment, you must isolate the cause. We have no independent variable. We have no hypothesis. No hypothesis. No science. No science. I showed you guys this earlier. This is about the history of calculus and how they're still not able to agree on a standard solution and how they're measuring points in space. George Berkeley, same discussions about calculus. All right, that's it for tonight, guys. Hope you guys enjoyed the program. This was the inaugural presentation from Kush Coast Communications. This is Brother Nicholas. If you guys want to get in contact with me, just reach out to Brother Matthew Craig from Lotus, and I hope to do more presentations. All right, signing out.